Are you finding that your laser is just too small for some of the projects you want to do, or maybe it doesn't have the power to punch through the material that you're trying to use? Hey everyone, I'm Steve. This is my workshop, and today we are taking a look at the iKier K70 Max. This is a 70-watt diode laser with an 800 by 850 working area. And if you can't fit it on this, you're probably looking at the wrong tool. So we're going to be taking a look at this laser, seeing what it can do, see how it performs with some materials, and try it out on a few projects. So if you're curious to see what this does, want to find out more, stay tuned. I'm going to jump right into it. So this is the K70 Max, and of course it does not come assembled. It comes in a pretty good sized box that you will need to pull all of the items out. You want to get them kind of out in order, lay them out, and also pull out the instruction manual. You want to read through that, make sure you understand all the steps. It's not too difficult. The instruction manual does walk you through things pretty well. You will need some Allen wrenches that are included with it, or you can get some straight ones as I'm using, and just step your way through the build. It's not too difficult. Most of the main parts are assembled. You just need to kind of bolt the frame together. You do need to connect the front kind of connecting rod to the stepper motor. And once you get that done, you can start putting the back rail on and then the main gantry, installing the module, connecting up the drag chain, and plugging in all the wires. It all goes together pretty well. It is a very sturdy frame, and everything does seem to be tucked away really nicely for all the wires and working well through the cable chain. So they've put some good detail into this frame. It is pretty hefty. And you should not have be feeling like it's a very lightweight frame. I'm actually very impressed with the rigidity and how well it comes together. Now it does ride on some steel rails and wheels, so those should be adjusted, but if you need to, the bottom nut on there is an eccentric nut. You can tighten those up. They do have belts that you will have to tighten a screw on to tighten up your belts. This is just kind of a little bit by feel. You want them to be snug so that it is not loose, but not so tight that it does a lot of binding. They, of course, then do have a pretty good size power module that puts out both 24 and 36 volts. That comes into the kind of control box, and then you do have power out to their air assist pump, which does have a variable knob on it for the flow, and it is controllable through the software. This machine does work with Lightburn, Laser GRBL, as well as AtomStack Studio. It does have some features on the control panel. So you have your power plug, and you have an HDMI cable going to a touchscreen that can be used for offline control, that also you can load files on through the USB. There is a USB key, so you need to make sure that you plug this in, otherwise you will not be able to connect your laser to your software. There is an accessory port for things like a rotary. This is an autofocus equipped laser, so they have a hard button on here, otherwise you can use macros in the software. And so on the back of the module, there is a small pin that it will touch off the material to set your focus at the top of the material. And then you do have your power switch and a status indicator. Power switch kind of doubles as your emergency stop. Over on the side, they do have a USB-C cable that goes to a split USB-C or USB-A or USB-B cable for connecting to your computer. And then you have your power in and power out from the module into the air pump. This is a 70-watt module. It is air cooled, so you do have the fan on top, and that will blow air down. They do have a thin air assist cone on there. And then it is switchable between 70 watts and 35. So you'll get an indicator of which one it is on front. So the switch down is for 70 watts, up is for 35 watts. And on this front panel, it does kind of have a bit of a power meter. So it will light up as it's going from 0 to 100% power. So that is the overview of the laser, the frame. There are some other accessories for it, such as an enclosure. They do have a double honeycomb. I have kind of a aftermarket one that I had on hand that I'm using for at least half the bed, but they do provide an option to cover the whole bed. And then they do have other accessories such as rotaries and fume extractors and such. So you can take a look at that and bundle some of those as you're looking at this laser. But that's kind of it about the hardware. Let's jump into some of our material tests and projects. All right, so I did do a number of material tests with this laser to kind of get a baseline of how it performs. And one of the staples of my shop is 3mm Baltic birch plywood. So went ahead and set that up in Lightburn. And so you see here, I ran it from 15 to 30 millimeters a second, and from 65 to 100% power to kind of get a baseline of where this laser will cut. And so you do kind of see this gradient kind of going up here as we work from 65 up to 100% power. We were cutting through at 15, 16, all the way up to just squeaking out at 22, 23 millimeters a second and 100% power with this one. And kind of to show you the back there, you see how the others were just struggling on the one direction there, top and bottom. And so that kind of gives us a good baseline, and that is pretty quick. I would say this is performing around maybe a 50 to a 60 watt CO2, maybe on up to an 80. It kind of depends on the tube and the beam and such, but definitely getting some pretty good speeds out of that. But one thing that I've noticed too is you definitely want to test with a different style of different shapes and different sizes, because sometimes with these smaller squares, it's not quite getting up to speed very fast. And so when you think it's cutting through on the slower speed, and then you get to bigger objects and it's actually getting up to that speed faster and staying at the speed, you might find some differences. So I did run it again on some a different test card that I've got, doing some circles. And this time we ran it from 16 to 24 millimeters a second and 50 to 100% power. And you see it is struggling a little bit here. We did just kind of get through at 20 millimeters a second and not quite getting through at 16, 17 until we got into like the 80, 90% power. Now there can be variations in the wood that cause this, but as you do different types of shapes, whether they're straight lines versus arcs, whether it has to do corners, and also the size of it, it's gonna make a bit of difference. So it's always good to kind of just step up your tests when you're really dialing it in, because there's nothing worse than thinking that it'll cut out based on this. You do a big project and you find you have a lot of gaps where it didn't cut all the way through. But armed with this information, I wanted to go ahead and see how it did with engraving on the 70 watt power. So I ran a raster scan test. This is from 150 on up to 400 millimeters a second, which is kind of the top speed for this laser. And then from 10 to 100% power to kind of get our gradient of engraving. And so this just runs across, kind of keeps a very constant speed, but it's upping the power as it hits these different boxes. So it's a pretty decent test for doing some engraving tests. And way down here at 150, you can see it's getting very dark. It's blowing through the top layer of the plywood into the second layer, almost the third, and leaving a lot more burn. But as we get up, we're still getting a decent gradient from at the 400 speed from 10 all the way up to 100% power, but it is a little bit lighter. So for my stuff, I'm thinking around 250 to 300 for a good quality. And this is for Baltic birch plywood. Every wood is going to be slightly different, but getting a little bit more into the mid-range of its speed for quality gradient of engravings on this. So I went ahead and ran this logo. It's a little bit bigger. It's about 6 inches, give or take, top to bottom, side to side. I did run the engrave at 300 millimeters a second, 100% power, and I had it at 0.1 millimeter line interval. I found over time that backing it off to about 0.9 is actually a little bit better, because at 0.1 on some materials, you get just a little bit of lines there. The cut I ran at 17 millimeters a second, 100% power. This whole job did still take about 19 minutes to complete. Like I say, this is about 6 inches, maybe 7 inches wide at the top here, about 6 inches tall, and covers a lot of ground, but did come out pretty well. It gave some nice dark engraving on this Baltic birch, and then also cut out the frame very nicely at that 17 millimeters a second. So before moving on from our 3mm Baltic birch plywood, wanted to run a bit of a kerf test because everybody wonders, what does the kerf look like on this? How much bigger is it? So to do these tests, and I've got a whole video on kind of figuring out your kerf for your laser, I run a set of squares to be able to run an average. And what we're gonna do is we're gonna measure in both directions, the inside cut and the outside cut. Then through the factor of math, subtract one from the other, you get the overall width of both, divide it by 2, so it would be just one line, top or bottom, or left or right. You kind of get your overall line width. So after doing that for all 4 squares, for both directions, we came up with an average of 0.16 millimeters for the total kerf cutaway, which is not too bad. It's right in there with your CO2 laser beams and such. So yes, it's more than maybe your average diode laser, but not so much bigger than, say, your typical 60 watt CO2 laser. And so your kerf offset, you're gonna wanna set that for this material somewhere around probably 0.8 to 0.9 millimeters and dial it in from there. So really not too bad. Like I said, I've gotten tighter ones with some lower power diodes, but that's pretty on par for like my 60 watt CO2 laser. So of course we want to step it up and see, it's a 70 watt diode laser. What can it cut? So I stepped it up to some 1/4 inch or 6mm Baltic birch plywood, ran some tests. I ran first in some squares, and so you can kind of see here, I was cutting through at even 7 millimeters a second, and these are 1-inch squares, all the way up to a 9 millimeters a second. And then I wanted to test the shape, and so I kind of take this raindrop shape, and so that way we get both an arc as well as a corner. And so even on those, I was getting through at 9 millimeters a second. And to show you the quality of it, so here's the cuts. This one at 6 millimeters a second, this is an imperfection in the wood. And so that's one of the reasons I say run your tests more than once, because it may just be an imperfection. But this is the top cut. I was running this on the honeycomb. There wasn't as much air underneath the honeycomb as I wanted. So there is some scorching on the back, and maybe it's a little exacerbated from the lack of airflow. So it could probably be cleaner on there, but overall things looking pretty well. And then if I can get that to zoom in and focus, that is kind of the quality of the cut. It is, caramelized pretty well, but it's not excessively charred. It's what I would expect out of a diode laser. So 1/4 inch Baltic birch plywood, which is a pretty dense, pretty heavy plywood. It's cabinet grade plywood, 9 millimeters a second. It's not too bad. So wanted to do a little bit of a test with some hardwood. So I have this kind of 1/4 inch red oak and started at 10 millimeters a second, went to 9, finally cut through at 8 millimeters a second. And this is a single pass. It's a little charred there, as you can see, but not excessively so. It's not really wiping off terribly on my fingers, but it is going to have that deeper look to it. So still at 8 millimeters a second, 100% power, full air on there. It can cut through 1/4 inch oak, which is going to be slower than some of your other materials. It is possible, but just keep in mind, you are going to get some pretty hefty caramelization on the edges. So as we look at some thicker materials, we're probably going to be starting to add passes. I personally don't like to run things in much slower than 5 to 6 millimeters a second in a single pass. You're just starting to encourage more charring, and you increase your risk of fire. So to test some thicker material, I knew getting through some really dense hardwoods aren't going to be what it does. And so I have some aspen here. It is like 3/4 inch aspen, and I ran that through the laser. Started at 6 millimeters a second in 3 passes. It did get through, and the edge is looking okay. It's not overly charred, but I was able to step it up all the way to 8 millimeters a second in 3 passes, and this is even cleaner. It's just a little more caramelized than it is charring. So if I show you the 6 and the 8, you might see a slight difference. The 8 is on top, the 6 is on bottom, maybe just a little bit darker, a little more prone to charring on that slower speed, but still able to get through. But again, I increased it to 3 passes. We weren't going to get through on 1 unless we were going super slow, and that's a big risk of fire. So having dialed in those speeds and those numbers, decided to go ahead and see if I can cut out a project from this board. And you see there is the cutout. Here's the kind of the remains of it. So there is some charring on the back. There was some flashback from the honeycomb. Again, that the more air you can get in the less surface contact area, this would be a good case for like a slat bed with a lot of air underneath it. You'll minimize that. But that being said, I was able to cut out this home sign. This is just a little bit over 12 inches wide with this base. It's about 3 inches tall, and overall looking pretty good. Again, it's a nice caramelized edge. It's not, it's not like a super charred, gonna leave marks all over. You're gonna wanna do a little bit of cleanup on this, and overall you'd probably wanna finish this some. But so again, this is clear aspen, 3/4 inch, and we ran it 8 millimeters a second, 3 passes, 100% power, and it took 15 minutes and 2 seconds to cut this out. So we talked a little bit about the kerf size earlier and that spot size. Some people will worry about it being bigger and unable to do engravings. Well, this is actually an image. Of course, it's not necessarily a photographic image, but it is a good little project. This is a 12-inch circle. Went ahead and downloaded this PNG file of a cat. We do a lot of joking around with my friend David over the Clack Shack, and a lot of times I engrave, his head. Well, this time, if you know his channel, let's just pretend this is Fluffy. Anyway, this was done in Stucky mode, and I had it on the 70 watt setting. It wasn't backed off to the 35. We ran this at 275 millimeters a second, 100% power, and the cut at 17 millimeters a second, like we did before, 100% power. This job did take 30 minutes to complete. Again, it's a 12 inch, and we were doing that 0.1 millimeter line interval. Overall, I mean, this looks pretty good. Now it's not, photographic quality. This is more like Illustrator quality, but you're still capable of doing engravings reasonably with this. I mean, this is not the machine you're gonna be using to do small photographic engravings on. You're gonna be doing bigger projects. That being said, I did wanna give it a shot with engraving something a little more photorealistic. So one of the things that diode lasers can do is they can engrave, they can remove the coating or they can remove the anodization on metal cards like this. And so I've used this one before. It's a little Grogu in the Mandalorian helmet, a little fan art there. And this was done with turning it down to the 35 watt setting. I had done a test card on engraving with the 70 watt setting, and it was just too much power. And even if you ran it at the top speed, it just needed to be backed off. You don't need a lot of power to engrave these cards, but it is doable. This was at 350 millimeters a second and only 40% power on the 35 watt setting. I did back it off to a 0.8 line interval and use Stucky dithering. And it's okay. If you get in really close, you will start seeing maybe a little less detail than you would with, say, a 5 watt diode laser. That's where those lasers with their really fine spot size on these are really gonna shine. And honestly, you're probably not getting this big, massive laser to engrave small business cards. Now, maybe you have a bunch of them, you wanna set out a big grid and do it that way. It is capable of that, especially if you're using just vector text and graphics. But just to show that it still can get some photorealism in there on that 35 watt setting if you want to. So I wanted to do some testing with some black acrylic. Now this is 10 millimeter or about 3/8 inch thick. And I did a number of tests to see what it would take to get through this. So I was running it again at the 70 watt setting, playing around with the air, sometimes with acrylic. More air is actually not what you want. You want to back off the air a little bit. Finally got through it, and you can see here, this did cut through 8 millimeters a second, 100% power, but 5 passes. And you do see it's kind of leaving that, you can definitely see some layer lines in there. It is not super smooth. If you were cutting 3 millimeter acrylic, this would be fine. It would get through in one pass, and it would probably be a pretty smooth edge, but it did take quite a few passes, and you can kind of see there, it just wasn't super clean. So it can cut thicker acrylic, but I'll be honest, diode lasers in acrylic, some colors are doable, thinner layers. If you're gonna be doing a lot of this, you really want to do yourself a favor, get yourself a CO2 laser. And I know I am gonna be asked this, can it cut through clear acrylic? Diode lasers have the wrong wavelength to cut through clear acrylic, but I thought I'd give it a shot. I had some 3 millimeter acrylic, some white, threw it under the laser, ran it through, and this is the result. You kind of see that it just speckled it a bit, and that's mostly where there was probably some imperfections or some dust. It just crackled a lot. It did not cut. Yeah, you could put markers on it. It would get deeper. But again, this is the wrong laser for clear acrylic. It doesn't matter how much power you throw at it when it's in that blue diode 455 nanometer wavelength. It can't see the clear acrylic. It wants to pass right through it. Even with a binder, it's going to be ugly. If you're looking to do acrylic, the CO2 laser is what you want to have. So I couldn't complete this review without at least attempting to use more of the work area on this one and use something that is too big for any of my other lasers. And so I went ahead and cut out a nice big cat sign. So we do have a black cat that he's one of our pets, and his name is Loki. So I kind of was inspired by that and went ahead and cut this out. This is a layered sign. So it's done in 2 layers of Baltic birch plywood. I had some blanks that were about 18 inches by 30 inches. So this is just a little bit under that, and went ahead and painted the parts, glued them together. I have a whole project video on this if you want to check it out and see more of the process between how I got the design in from Creative Fabrica and then set everything up, did the glue up and the painting. So I'll have a link for that if you want to see more of the details of that. But this is just an example of doing something a little bit bigger on a laser like this. This definitely isn't something I could do on any of my smaller diode lasers or even some of the desktop CO2 lasers. It just requires a bigger working area. Now you could use pass-throughs in the print and cut feature, but it's so much nicer just to drop some material down there and let it cut out. And again, this only used up about, it was the full width of the laser, not quite, but only about half the height as well. So this could have been increased in size yet and still fit on there. But this is really the reason why you might get this laser. You're wanting to do some larger projects, some larger signs and such, and be able to do them without having to piece things together or do kind of like tiled cuts on there. It's just going to increase your speed, reduce any errors in it, and let you scale up your projects. So those are all kind of the initial projects I ran through on this laser. Tried to give a good overview of the capabilities with some thicker materials, but also highlight some of the things you can do with that larger work area. Really, that is kind of the primary reason you would look at this, is that you need more working area. You have bigger projects. Maybe you're doing a lot of like sign work and such, and it really needs to be in one piece on a bigger piece of material like this. That's where you're probably going to be looking at one of these lasers to be able to, get those done easier and, without a lot of piecing together of items. The caveat to that is it does take up a lot of space. This table you see it on is kind of my assembly bench, and I've already had to enlarge it for larger lasers like this just to be able to kind of test them out and review it. But it is 4 feet deep at this point and 5 feet wide, and there's not a lot of extra space over here. As you can see, I've got the air pump and the power brick there. There's maybe about 10 inches left on this table. So it is going to take up a fair amount of space, and you're going to need to dedicate to that. The other thing is, as an open frame like this, I was able to run it with my shop doors open and such. They do have an enclosure for this, which is also going to take up space. So you're just really committing a good chunk of your shop and a large table to be able to operate this. And if you have that need, great. You're going to find the space for it. What I would love to see is, a 70 watt laser that is, 850 to maybe even 1,000 wide, maybe about only 500 deep. I would cut this down by maybe about 1/3. I think it would be just easier to fit into more workshops. And it's probably going to be easier, once you get in this into an enclosure, you still be able to reach various areas of the material. So I would love to see someone come out with, that size. Doesn't need to be a big box. Just make it a rectangle, make it less deep, but keep it wide. It'll still let us do a lot of this work, and I think it would fit into more people's workshops. So those are kind of the caveats to this laser. Outside of that, it ran really well. Lightburn picked it up, and the autofocus worked very well. The air assist, I love these pumps. These work very well. I'm overall happy with the performance of it. I'm just concerned it is a lot of space to dedicate to this laser. And, you're not just going to hang this up on the wall or set it under the counter or the workbench when you're not using it. you got to dedicate some space to it. That's kind of just the big caveat to this laser. But if you need the working area, you're going to have to find it. So I hope you enjoyed this kind of overview review of the iKier K70 Max. It is a big laser, but you may have a need for that both in the power and the size of it. And if you want to find out more, I will have a link down below to their website where you can check out the laser and all of the packages and options they have for it. That will be an affiliate link. So if this information helped you out and makes you want to pick that up, I'd appreciate you using that link. It does give a small kickback to me and tells the company that you found my information useful, and hopefully I'll get to work with them more in the future. If you have any questions or comments about this laser, go ahead and leave those down below. I'd love to hear your feedback. What did you think about it? Is this something you could see in your shop? What would you maybe want to see different? Or what projects would you do with it? Always love to hear from that, because sometimes I get inspiration from you guys to come back with another project video and or even more testing with the lasers in my shop. Anyway, thanks again for watching this video. Before you leave, please hit that like button. And if you're new here, I hope I earned your subscription. Go ahead and hit that subscribe button. I do a lot of project videos, instructional videos, and review videos like this on lasers, CNCs, and other things in my workshop, and try to make it fun and educational for you. So if you like what you saw, I'd love to see you back at my next video. Thanks again for watching. We'll see you soon, but I hope in the meantime, you get out in your workshop and make something too. We'll catch you next time.